Okay, everyone, welcome to this session about ROS and Kubernetes. And then my name is Ricardo Telle from the Construct, and I'm just being the chairman of the session. The star of the session is Tomoya Fujita, that you probably all of you already know from Sony. He's also a member of the ROS TSC committee, and he works as software architect and engineer at Sony at the RDC US lab in the United States of Sony. So the audience is all yours, Tomoya.
Okay. So hi everyone. So I'm Tomoya. So today we're gonna do some demo, and I will focus on how to use the Kubernetes for ROS perspective, not too much details about how it works, Kubernetes perspective, because the ROS is one of the use cases for the Kubernetes. And I'm going to explain a little bit with demonstration. And if you have any questions, just you can speak out, or you can type in the chat what is your question or anything you want. Okay. Okay. So let's get started. So first, for doing this demonstration, we do need first a cluster. So I already set it up because it, we can save it. I can save your time. So in this time, we are going to use the kind. It's like virtualized Kubernetes cluster, which can be constructed on the single system. So it's very useful to try out, or if you want to test something as a container application, it's very useful to just try it out. So the kind, for using kind, it's easy to use. It's just a single command, but internally it uses a Docker container. So you can see my screen, right?
Yes, we can. It's a little bit small because so many things on the screen. Yeah, a little bit small, but it's okay. Yeah, that's better. Yes.
Better?
Better.
Much bigger?
No, for me, it's okay. I don't know.
So now, I'm sorry? Good enough?
Looks good, yeah.
Okay, yeah. So I already started the kind virtualized cluster, and there are, as you can see here, there are two containers. So each container appears to be the physical node for the cluster, but the cluster is already there. So yeah, so the kube control is the command to access the Kubernetes cluster. It is product API provided by the API server, and we can see there are two physical nodes. It appears to be the physical node, but it's actually a container running in your single system. So we have two nodes in this demo, and that's the bottom line. That's a start line that you need to set up the cluster. If you want to use the physical machine, that is fine. There is like a documentation in this project how to set up, including Raspberry Pi 4. So there should be no problem. But in this case, we're going to use the virtualized cluster. And I already set up like dashboard. So dashboard is, let's see. To set up the dashboard, there's already a description file, which is included in this demonstration. And basically, the dashboard is does the same thing with the CLI. So you can see that if you type in the kube control get node, we can see the two nodes, right? So this is actually accessing the Kubernetes API. And dashboard, it does the same thing. So, but it provides a GUI, so it's much better to see. But as you can see, that there are two nodes running in this cluster system. One is kind worker. This is a worker node, and this is a controller plane, kind controller plane. So dashboard provides almost the same thing, but it's easy to use.
And one question, if I may. So, and this dashboard, where does it has to run? So it has to run in the same machine.
Oh yeah, dashboard is also running in the cluster. Yeah.
And
So
then
the dashboard, yeah.
And
So
uses ROS bridge somehow.
No. It's just a Kubernetes component.
Kubernetes. Okay.
Yeah. So you can see if the namespace is default. Default means for your application user space. So if we change the namespace for the all namespaces, you can see the dashboard container is running inside the cluster and provides the API to be accessed by browser.
Clear.
So everything, pretty much everything is, once the cluster is ready, we can control any container application inside the cluster. Okay. So let's move on. Oh yeah, so there is, I want to explain something about container network. So when you start the cluster, there is a requirement, which is the container network interfaces. So after you set up the cluster, the Kubernetes requires the container network interfaces that can be bound to your application container. So in this picture, the frontend is the default container network interfaces. Let's say the frontend is going to be bound to your application running inside a container, and it just appears to be the like the network interfaces that provides a VX1. So this CNI implementation is going to be required unless you want to bind your old containers to your host system network. So it's just one of the requirements. It depends on the use case, and there are many CNI plugins because in Kubernetes aspect, it does not care about the implementation. It just cares about interfaces to be called. So Kubernetes does not have any idea what kind of like implementation to be called, but you can choose. So I introduced 3 like a CNI plugins in this documentation. Yeah, this section. So the first one is frontend. Frontend is like the most default, the CNI implementation. So it's, if you don't care about like a specific feature or security, you can just go ahead to use frontend. It's just the most likely the people to use because it's a default. But the downside when you use ROS or ROS2, especially, it does not support multicast. So if you want to deploy the ROS2 application using a multicast service discovery, that is going to be the problem because it does not support multicast, right? So if you are using DDS or ROS2, which requires multicast packet, probably you cannot use this. On the other hand, the second one is Weave, which I do pretty much like because it supports UDP multicast. And also WeaveNet, it provides a mesh network, which means you can go over the network. You can connect 2 different networks out of the box. So if you want to use like a ROS2 or DDS, maybe the WeaveNet is going to be like a first candidate because it supports multicast. It just works out of the box. So during this demo, we will use the WeaveNet, which by the way, I already deployed. Let's see the pods or namespace, the Weave, this one. So the WeaveNet GX6 is now running in worker node and the controller plane. So if you start deployment, hey, I want to use Weave as a network interfaces, and Kubernetes takes care of that everything, and Kubernetes is going to deploy the WeaveNet container for each one node, physical node, and then Weave is going to connect to each other to provide a VX1. Yeah. And Weave is fine, but there is actually the problem that I want to mention. The weave is maintained by Weaveworks. It was maintained, but now that's kind of like EOL. So the sub-community members are working on, how to keep the maintenance and how to, like keep distributing releases, this kind of stuff. So, but basically that kind of like EOL. So that's something you want to know as a status for the WeaveNet. And a third option I introduced during this demonstration is Cilium. So Cilium is now like, I think it's really famous, and scalability and security perspective is pretty good. So, and it takes advantage of the Linux kernel eBPF to accelerate the process, because if the node is going to be like thousands of robots or something, there is a problem for routing, right? Because if we deal with like IP table or something, it's going to be the performance problem. But the Cilium takes advantage of eBPF, which is provided by Linux kernel. So I'm saying like all of the hard work is going to be in the Linux kernel to routing the packet. That means no user space context switch or copy in or copy out. So that has to be faster. And also that provides the very good observability and security features. So maybe if you want to use, if you want to work on the actual product, maybe the Cilium could be the candidate. Okay, so let's jump on the actual demo. The first one is the ROS 1 Noetic. So the first demonstration it's like a typical use case. So the use case is like, hey, we have two nodes running inside a cluster, and I want to deploy some, like a ROS 1 application containers as a single pod for each physical node. And all we have to do is ROS 1 data set. Okay, let's do this. Let's see that.
Tomoya, can I ask a question? Yeah, sorry for my basic question. Okay, so I'm not into Kubernetes, but when you are talking here about node, for me, node is a ROS node.
Sorry.
Here you're talking about physical computers.
Physical computer. In this case, during this demo, we use a virtualized node, but let's say it's Kubernetes node. Kubernetes node is computer, not ROS node.
Okay. Okay.
Yeah.
Okay.
So, yeah. So thank you very much for asking that question. Yeah,
okay.
That's confusion.
Okay.
Okay. So I just deleted. So once again, so let's apply this ROS 1 demo set. So demo set is a Kubernetes custom resource that if you say, let's say, if you want to deploy the demo set is like Kubernetes is going to deploy that demo set every single node automatically. If you have thousands of robots, hundreds of robots, it doesn't matter. If you do use the demo set, Kubernetes is going to deploy that specific application described in this YAML file, to any one of them. So in this case, let's just start.
Okay, so then in the example that you are doing is only for two.
Yeah. So we only have two nodes.
Two nodes.
Yeah.
But we could have 100 robots.
Yeah.
That will be the same application in 100 robots.
Exactly. Just a single command. So the use case that we have demo set is like maybe you have like system services, right? More system like a ROS 1 application something. So in that case, hey, I want to deploy this application every single robots, and maybe you can use the demo set, because if you use demo set, the Kubernetes is going to take care hey, I need to deploy these pods or application container, every single one of them. It just automatically happens. So as you can see that, like a daemon set 1, 2 has been deployed and each node. Okay. And let's say.
Tomoya, question. So at some point you must have defined each one of your robots as a node, right? As a Kubernetes node?
Yes, you have to join. So I already set it up, yeah.
You did that before this demo, yes. Right? Because we didn't see you do that step. So so do you have to install like the Kubernetes runtime or something? Or I don't know. How do you set it up as basically a Kubernetes node?
Yeah, first you need to install like Kubernetes packages.
Okay.
And after that, first you have to do is like you have to set up the master, because the API server has to be ready to accept a node. Node by here is Kubernetes node, worker node.
Right.
Yeah.
So you set up a server first, and then you can set up the individual client nodes.
Exactly. Yeah.
Okay.
I just did skip that procedure because it does not relate to ROS perspective. So it's just about how to set up Kubernetes.
Right. Okay.
Yeah. But basically, your question is correct. So you have to, like join the node to the class system. So if you have like 100th robot, maybe you can write some script to join the cluster from the worker node once the master is ready.
Okay.
Yeah.
Thank you.
Yeah. So now let's see this console. So the pod is ready. So the application is running. Let's jump in. ROS one master like this. Okay. Yeah. So what I did here is like, hey, we can see that the demo set is running, right? So that container is running. So, and sometimes, hey, I want to make sure that I just want to jump in that specific container to make sure that everything works okay, right? So what I did is using Kubernetes API to log in this specific demo set. And in this demo set, there are 3 containers. So I specified a ROS one master. So now I am in the container, which is running in the cluster. And so we should be able to like ROS Robotics set up a bash ROS topic. This you can see the chatter. So the application is running. So what I did here is I just jump in here, ROS master container. This is container, and pod. The pod is like a pod can have multiple containers, but pod behaves like a localhost system. So what I did is I logged in this ROS master container and to see that actually the application is running. So now the using command line in the ROS master container to see the ROS topic pod like application is working as expected.
Hey, just a quick question. So for the layout of your cluster, you have primary node and worker node.
Yes.
And to my understanding, normally we would have that listed as like a master node or like an orchestrating node.
Yeah.
And so is primary node the master node in this circumstance is kind of my first question. Okay.
Yes.
And then
I just change the name because
and I get this isn't necessarily like this is more a demo layout,
Exactly.
But is the understanding for using daemon sets for your robots is that we're assuming that each robot will have an individual node
Yes.
on it. Okay. And then with that, does that mean that oh, I guess I would be more curious, and this might be outside of the scope of what you're trying to demo today, since I know a lot of people here seem to be trying to just grapple with Kubernetes. But I'd be curious to see how would you sort of set up your sort of cluster configuration so you can have that distributed Kubernetes cluster.
Sorry, I don't understand your question. So,
So I'm going on the assumption. So are you assuming that these nodes can be physically on the robot, or are you just saying a centralized server?
oh, these node means, for example, like a worker node.
Yeah.
Worker node is just an operating system instance.
Yeah.
Yeah.
And so I'm thinking from like a production standpoint, right?
Yeah.
Would or what would be sort of an opportunity to use Kubernetes if assuming it's all one cluster while having the nodes on individual robots?
Oh, I see, I see. So
Yeah.
that depends on the use case, right? So,
Right.
for example, some use cases like, I want to have a single cluster in the factory, right?
Mhm.
And then each robot have the main computer, which can join to the master cluster.
Yeah.
So then the far edge devices, maybe you can have like a microcontrollers for the far edge devices to control actuators, sensors, or something like that, right?
Right.
So maybe using the host system network to connect each other.
Okay. Did you
Yeah,
know
it depends on use case. If you have like a multiple CPU, for
so
example, if you have robot, let's say that robot has like a 5 CPU, 5 operating system.
Yeah.
If you want to, you can join all the, like all nodes in this case system in the cluster, and then maybe you can label this computer is the brain, and this computer is to like a controller or navigation or something. So based on this labeling or capability, you can manage all the fleet.
Yeah. Thanks. And do you know if there are any tools that can help enable that you've seen? For like being able to have potentially nodes join and leave the master more freely?
Oh, not sure. I don't think that the CNCF project provides any kind of stuff, but there's something we can do is like a system D or something.
Right.
So yeah. So
Okay,
yeah, actually, that's a good question. So that is something I was going to do, because from user's perspective, hey, I don't want to do any this operation, right? I just want to power on my robot, and the cluster should be ready without any operation. I think that's totally understandable. So that's something I can do is like maybe like a static to master and already fully allocated certification or something, and all the edge nodes can using system D to join the static server or something. That's something we can do. Yeah.
No, I've definitely been interested in looking into that. So if that becomes like a discussion outside of here, I'm definitely open to that. But
yeah, maybe
I
we
know
can
this
create
is well out of
something.
scope probably for what people are worried about right now. So yeah, thank you.
I think it is useful.
I also have a question. Can you hear me? All right. So what would be the difference between using this setup here, your Kubernetes setup, or for example, I'm using say Docker and maybe Usernet or some Portainer perhaps? What would be the difference?
The difference between like a virtualized cluster and a physical cluster?
No, I'm saying this, you have two computers here now with both of them running instances of ROS on it. So for example, if I had like Docker running on two different computers or two different AGVs, and then I'm some sort of communicating within those, what would be the difference between that?
We lost your sorry.
Yeah, your audio is not working.
Can you hear me now?
Yeah.
Yes.
Okay.
I said you have your Kubernetes set up with two computers. So I'm assuming
Yes.
basically one of them is like a main computer, the other one is like an AGV of some sort. I'm just assuming. I'm saying what would be the difference between this setup and say, for example, I put Docker on both different instances of Docker, maybe on two AGVs, for example, and then I'm using like a Portainer or maybe, for example, USARnet or some local network to like communicate between those two AGVs. Like, what would be the difference? What is the benefit of me using this one as opposed to that one?
I mean, like, if I'm not mistaken, are you saying like a comparison between like a Kubernetes and just Docker?
Yeah, I don't understand the difference yet.
Okay, so you can, if you want, I mean, like you can use Docker. I mean, like application logic is exactly the same, right? Because Kubernetes doesn't even know what's inside a container. But what Kubernetes provides is like a fleet control. So if you want to use Docker directly, that's fine. And you don't have to pay any taxes for the Kubernetes, like a system, like management or something. That is fine. That's one of the use cases. But Kubernetes provides like a fleet control. So if you want to, you know, for example, if you are dealing with like 1,000 robots in the factory, that's going to be the problem, right? And eventually you need to update your application sometimes. Or if you want to deploy some specific application, hey, let's say 100 robots out of the 1,000 robots, and I want to deploy this specific application for the debug perspective. This is one of the use cases, but you can do that with Kubernetes with a single command, and also the capabilities. For example, you know, like the robots has many dependent capabilities. For example, some robots have ears or mics, or just a computer. So if you tag those robots, hey, this computer, this machine has like arms, legs, or something capabilities, but we can deploy the application based on these capabilities. It's fully managed by Kubernetes.
Okay.
It's just how to use, how you want to deploy the application, I think.
All right.
Yeah.
Can we say that Kubernetes will be the manager of Dockers? So you can have your applications in Dockers, but then you have to manage them manually. So you have to go to the robot and then tell update and so on. So you have to go one by one. And then Kubernetes is the one that manages, right?
I understand.
I mean, it's not only that. The Kubernetes provides more. So the next demonstration will show that how service discovery for using Kubernetes. So it's not only for the fleet management. Kubernetes provides like service abstraction and capability abstraction and you know, like hardware you know, like binding to the container runtime, and also the, you know, these security perspective. So I think the next demonstration will show something, you know, like the different compared to the first one.
Then let's go. We are
Yeah.
I do have just a very quick question. So for this demo that you're showing currently, what are the environment variables for each container? I think, were you just using localhost for ROS master URI and all that, or how exactly are the publisher and subscribers seeing ROS core here, for example?
Oh, so yeah. So previous demo, so the ROS master is running inside the pod for each pod. So this is the master in the container, in the pod. And the pod is like, it appears to be a local host. So the ROS topic or ROS, you know, like subscription, whatever, is going to connect this ROS master.
Okay.
Because
cool.
it is in the local host.
Yeah, just
in this
localhost
particular
for that,
case, yeah.
For that pod. Okay, thank you.
Yeah. The next one is going to be different. So let's deploy. Now we have like a demo set running in a cluster. And if you want to delete it, just could be control delete and specify the demo set file. And that should be gone. Okay, it's gone now. And next one is to apply first one. So the second demonstration is a little bit different because the multi knows the ROS system. So the ROS master is running in the, oh, sorry, I need to label. For that. Okay, so let's first the explanation. So we need to label the primary node as a master, and we do label the worker node as a worker. I will going to do that later. And after that, we will deploy the ROS master and publish in the subscriber. And in this case, like we are going to construct a ROS1 system with multi nodes. So the problem that we have is like how can we connect? How can we know where the ROS master is running, right? What's the IP address provided by Kubernetes? And that interestingly, that Kubernetes decides the VX1 IP address when the container is running. So we cannot know. So that's the problem. But on the other hand, Kubernetes provides like a service abstraction. So if we specify this, like create the service, which is like a, which provides like a DNS. So we can DNS this ROS master service to asking the Kubernetes, hey, what's the IP address for this ROS master? And we can get the IP address dynamically, so that these publisher, subscribers, whatever, can connect to the ROS master dynamically because it can DNS from that service name. So in this case, what's good for us is it does not care where to run ROS master because it can be anywhere. Probably you don't have to know, right? Because Kubernetes takes care of that. So that's a good thing. So, but before that, we need to label. So this is label. And you can see the current labels for each node. But in this demo, we do need to add the nodes. The master node is like master. The worker is worker. It's just a key value pair, but you can use it, like for how you want to deploy it to specify these labels. Node type is worker, and you can also see those information. For example, like control plane. See that node type is master. This is a label, and node type is worker. So based on these capabilities, I'm going to start. Let's see, what should be running? See that? So the ROS core is ROS master is running in the master, and listener is on the master. And talker is on the worker. So these are controlled by label. So I specify, hey, ROS master, you need to run somewhere labeled with master. If you add the label, and if you have more nodes which is labeled with master, Kubernetes just decide one of them. But in this particular case, we just have a one. So the master is running here and the listener is running here because it is specified by us, and talker is here. And after the container initialization container is initialized, it can DNS the name provided by ROS master. Hey, the ROS master IP address is blah, blah, blah. And then the subscriptions or talkers can connect to this ROS master. That's why it is running. And also we can, for example, we can just jump in this specific container using GUI. To each other. So, and applications running. So this is like a service discovery. One of the use cases, for example, like even with ROS2, like DDS or ROS2, discovery process is pretty heavy. So sometimes we will, set up like a discovery server, DDS or ROS2. So for doing that, the problem that we have is we application engineer maintain that the service discovery, right? But we don't want to do that. So but in this case, if you want to use Kubernetes, we can take advantage of the service discovery provided by Kubernetes. Everything is going to be taken care of by Kubernetes. You don't have to know anything about it. That's the use case here.
So the listener and the talker will survive if Kubernetes decides to restart the ROS master?
Yeah, I think so. Yeah.
And they'll reconnect and there'll be no issues because there'll be the service discovery?
Yeah, so the thing is maybe that the restarting, I think the container, the listener and talker container is going to be restarted anyway. So after the restart container, because it fails, right? So the master, if the master is ready, I think it's going to connect the new IP address.
So is it going to get the same IP address internal?
No, I don't think so.
Okay,
No,
so if there was an existing publisher, it might not be able to contact the ROS master again because it might have a different internal IP.
Yeah, so you have to integrate some specific process in the application logic, or the container fails. If the container fails, the Kubernetes is going to restart that specific container. So once the container is restarted, it's going to DNS again, and then it can get a new IP.
So it will use DNS name. So if that translation gets updated, then you should be fine, right?
Yeah.
But if it's raw IP, then not.
Yeah.
If I'm right, is that because you're keeping all of these ROS nodes as containers inside of one pod, right, per the daemon script?
Yeah, it depends on your use case. For example, like if you want to have for example, like navigation, and there are maybe like 10 or 20 nodes, ROS1 nodes or something, right? So if you want to have those containers in a single pod, it can connect as a local host. So I think it's just a balance and use case. Like if you care about the performance, maybe you can put every single containers in a single pod. Or if you want to, like a more distributed like application,
Yeah,
you can, yeah.
I'm guessing the trade-off though would be if your master is not associated per that node, then you wouldn't necessarily be able to network to services. Kubernetes services. You wouldn't be able to network to Kubernetes services without the master node. Whereas with containers, I'm assuming those are more local references. Is that the kind of assumption we can make?
You mean like if, like, are you talking about like a use case one?
So, yeah. So in this case, each of the individual ROS nodes are connected under a pod, right?
Yes. Yeah.
And so the problem that was brought up is the idea that if we lost connection to the master node, we could still communicate to our local ROS nodes, right?
Yes.
And so I was sort of wondering, and my assumption is kind of this wouldn't be the case if we had multiple pods that we were trying to communicate to through Kubernetes services, which is the networking side. And my assumption would be we wouldn't necessarily have that because if the Kubernetes master node was down, we wouldn't have the DNS. Is that
exactly? Yeah.
Okay.
Yeah.
Thank you. Yeah, sorry, there's a lot of like term overlap between Kubernetes and ROS, so and they're for completely adjacent things, which does not help, but
yeah, it's Kubernetes to understand Kubernetes is really hard work, like how it works. Yeah, it's like a huge concept and architecture.
Yeah, no, I'm glad you're covering this.
Yeah,
that's awesome.
So let's move on to ROS 2. So maybe it's been 40 minutes. Maybe I can do this demo. Yeah. So the ROS 1 deployment should be okay. It's gone. So now using ROS 2. So the ROS 2 is, luckily we don't need to have a master in the ROS 2 application. So what we're going to do here is just to deploy some application, and we don't specify to where to be created these containers. So we can just say, hey, I want to run this six like ROS application, and Kubernetes can decide where to run. Okay. So as you can see, like a list now 1, 2, 3, and all these numbers are like a topic name. So we have 3 topics, and also the publisher token 1, 2, 3, and it's a pair. Number 1 is going to connect to each other to like a publish and subscribe topic. So let's see. Yeah, before that, there are 2 containers running in the master node, and 4 containers running in the worker node. So basically, the Kubernetes is going to deploy the application, user space application, not master nodes, because the Kubernetes itself needs the computation to manage the fleet, especially for the master node. So it basically tries to avoid to deploy the user space application to the master node. That's why we have 4 containers running in the worker node. But anyway, so let's jump in this container. Roll. There should be 3. Yeah, chapter 1 to 3. This is from Toka 1 and Toka 2. And Toka 3. So everything seems to be working. So because of the distributed system provided by ROS 2, sometimes we don't need to care about where to run, right? So hey, I want to run this application somewhere. I don't care. And we can just connect using topic or services, right? So that's the use case. I think the typical use case. Okay. The next one is localhost. This is sometimes required because I think most likely like a test or debug use case. I want to like test my application using the localhost only, not distributed. To like affect, I don't want to affect anyone else in the cluster. So so in this case, we need to specify the environment variable, which by the way we can do that in the description. You can just type like environment variable ROS localhost only 1. So that's all you have to do. So first we need to delete. To localhost. So we have 4 containers running. So we use daemon set. Daemon set 1 is like for example, this one is daemon set 1, and this one is like a daemon set 2. So as total, we have 4 containers running in the cluster. So let's see. It's there. Should be working. this is, sorry. This is a use case about like a specified environment variable. It's just easy. You know, you can see that I'm not going to show it, but you can see that description file and how to do it. It's just you know, like write some lines about like environment variable to bind the container. So I think we are running out of time. So the last demonstration, I'm not going to do it, but let me explain. So this is really useful. So
We have time.
we have time.
We have time, maybe not for
But
any
I
questions.
would like to have like a question time. So I'm going to like quickly explain about this one. So the last demonstration, we describe directly to the container the pod description. Hey, I want to use this environment variable should be bound to this container, right? So, but it is too, you know, like it is really, the information should be isolated because the configuration and the application logic should be isolated. I'm saying like application logic should be agnostic from anything about configuration. And in this case, in this like use case, we can use like a configuration map, which is provided by Kubernetes. So the configuration map is like the configuration data, something like the environment variable. In this particular case, for example, a ROS domain ID, or maybe if you want to use a localhost, of course you can write the ROS localhost environment variable in that configuration map. But I'm saying like the data object is totally different. So you have to first you need to, you know, like focus on the configuration map, how you want to configure, right? And that data object is different, you know, like a data object. And then we can bind that configuration map managed by Kubernetes to any containers. So for example, like in this case, the ROS domain ID 5 and I want to use a fast DDS. And this is like configuration data. And we can bind this configuration map to any containers running anywhere in the cluster, because the Kubernetes provides shared storage. And when the container is running start, it's going to bind those data objects as a configuration to that runtime. So I'm saying, so in that case, like you can manage more efficiently about the configuration, you know, agnostic from the application logic. I don't know. it's hard to explain. Yeah, so I'm not going to do the demo, but this is a use case about like if you have like many robots or many environments, you eventually have many configuration, right? You don't want to bind those configuration data to the application logic. Maybe you want to maintain, hey, this is a configuration for the test. This is configuration for the product or something. So all you have to do is, hey, I want to deploy the same application should be okay. Application A to, you know, to use the configuration A at this moment. But when the production phase, you know, like this same application should be using like a configuration B or something. So it's just like a management for the data object.
It could be, for example, with a robot that we already have at the customer's facilities, and then we want to run some tests on the robot to see. So we deploy the test application with a different configuration.
Yeah.
So it's the same, sorry, it's the same application, but with a different configuration.
Exactly. So the use case is like, I think what's good for this use case is application engineer doesn't even care about the configuration. Application engineer should be focusing on only application logic. And the managed business logic developer or something, hey, if you want to test your application, you can use this configuration data. And the application engineer does not even know anything about configuration, right? They just want to know, hey, my application is working okay or not. So that's the use case here. Yeah. So, okay, so that's pretty much all the demonstration. So yeah, we have, I mean, like I have some issues. That's something I want to, you know, do more. And something I want to point out here is maybe, you know, I can, you know, develop some script to set up the cluster, because you don't want to type in, like every time your system powered on to set up a cluster, right? So maybe we can have some script to set up a cluster. And also this one is interesting. So the security is really pain for me. I mean, because ROS provides security enclaves, but you have to maintain security enclaves for each node, each like a machine. So if you have like let's say like 100 robots in the like in your factory, you have to distribute. You have to make sure that every single like a machine can access to those enclaves, right? So that ROS provides like, hey, you can have like security enclaves, but management is your responsibility. But it's actually paying for the user. So something I want to do is like maybe we can take advantage of a configuration map. So the first we have to like we can create like based on the requirements, we can create security enclaves and the configurations. And my idea is we can load those information as a configuration map to the shared storage. And everything else is just, hey, this application should be bound to this security enclave in the Kubernetes description, just like an environment variable. So it's really easy to bind, to like manage security data object and application logic, because it's isolated and we can manage like in different perspective. That's something I want to try. And the other thing is like NVIDIA device plugin. So eventually for edge IT devices, we have like a GPU acceleration on like a physical machine. So particular case is like, hey, I want this, I have the application, but I want to run this application with 2 GPU. I think that's going to happen most likely, right? So in this case, we have to specify, Kubernetes should be aware about how many NVIDIA GPU is running this specific physical node, and how we can bind this specific application to that NVIDIA GPU, right? So that should be managed by Kubernetes. So that's something I want to try. Yeah, that's pretty much for me. So I think I'm done. So we have like 10 minutes. So if you have any questions or comments.
Okay, thank you very much for your presentation, Tomoya. And then, yeah, now it's time for questions. Guys, you can switch on the mic and.
I think there's one nice question in the chat, which
yes.
is incidentally also the same question I wanted to ask. Is Kubernetes a good choice for robots in a Wi-Fi network? What about robots in different facilities connected to different Wi-Fi networks?
Oh, you mean like a different network?
Yeah, that was my question, because Kubernetes is designed for servers in a data center, not for robots connected to an unreliable Wi-Fi network. How well do you think this is going to work for those kinds of robots?
Oh, I would have like some comments. So that depends on actual use case. So I actually try to use like a Kubernetes in my home using Wi-Fi. So yeah, that's something actually you can do. And also, if you want to, you can create the multi-cluster connected to each other. So if you have like the services in the cloud infrastructure, and on the edge, the different class system, like maintain all robots, and you can connect those clusters, like set up the multi-cluster system. Or, so I'm saying that there are many approaches. Or maybe you can have like a VPN like solution to connect everything. I would not say that's the good idea, but that's something we can do, right?
But maybe this is a good one for robotic manipulators that are connected to a LAN network through cable. So I could see that this is going to work well for them. Yeah, thank you.
Yeah.
But some of this regarding the different networks does WeaveNet actually take care of that overlay network? So that way you can have the same one IP space across, because it's just an overlay.
The Weave, we confirmed it. So what we verified is like we have 2 different networks, and Weave can connect to each other. If Weave tries to route the packet like as much as possible. So if your network can be accessible in any ways, the weave is going to try that route. Of course, the performance is not good, but it is going to, like send the packet, like as much as possible. Yeah. Andrew, go ahead.
We have a question from Andrew.
Great, yeah. Yeah, thanks a million for that. It's really interesting. I've been thinking about the best ways to deploy software to robots for a while now, so great to hear about all this. I had a question about the update lifecycle. So in this, you run the apply commands, and the update goes out sort of immediately. But for robots that are presently engaged in a task that can't be interrupted, or they're offline, or they're just powered down, have you come across any ways to have more control over that update cycle, to either defer it to a different time, or for the robots to request it at a time that sort of suits them, rather than just kind of push it out all at once?
I'm sorry, I don't quite understand what the question is. So
yeah,
you're asking the question like the life cycle, right?
Yeah, but like the timing for that update. So rather than sort of run the apply commands and have the update go out to the fleet, have you found other ways for the robots to control that time? Like if you try to apply this update to the fleet, but some of the robots are busy.
I see.
Yeah. Can you sort of have better control over that?
Yeah, that's a good question. So not really. So maybe that's something, I mean, like that's a very good question, because that's, I think, the use case for we have like edge IoT devices, right? So because the service, if the application is abstracted by the service, we can have like a multiple backend like a running application in the cloud infrastructure. So we can update like a rolling update, right, without any downtime. But I think that's going to be the problem for the edge IoT devices, because the robots would stop, right? Because if the application stops and updating the container.
It's just something we've come across. Like
so that is that's exactly we are looking for. We are not saying like Kubernetes is perfect, because it's actually developed for the cloud infrastructure. It's not suitable for the edge. So the question comes to me is like, what's missing, right? So what's missing, and we can contribute. That's the basic idea what I do here. Yeah,
I think it'd be interesting to see, if there could be better way, it's just come up with a problem. So, but it was great. Thanks, Mil.
Anything else? We are almost time.
One quick question from my side. Any recommended size for the pod? Because in robotics, in ROS, usually the applications, they go to the gigabytes very quickly.
You mean like a container size?
Yes, exactly. For a pod, if it has to be restricted in order to be, efficient in order to manage this. Is there any restriction or not? I know that this Kubernetes comes from microservices or management of microservices, right? They are very, very small applications.
Yeah, I mean, like it depends on the use case. So the application engineer, just for their perspective, is like they do develop the application container. For example, like a Docker image, right? That's the end of the story. And everything else will be taken care of by like a business logic. How you want to, okay, in this particular case, I want to create the pod with single application container, or I want to create the pod with 3 different application containers. That it depends on the use case. Maybe it's related to performance, because the application is, if the application container, everyone is inside a single pod, that's a local host communication, right? So maybe the performance is good, but the downside is if something happens in the pod, everything is going to be down, right? So it's not really distributed application management. So that's, I think it's trading off, right?
I see. Okay. Okay, any final? Okay, no, we are out of time, so we have to finish here.
Okay.
We have several messages here thanking you on the
Yeah,
chat.
please try to, if you have any questions, just let me know. I'm interested in technical and use cases, this kind of stuff. Maybe you can create issue or just try to make contact with me directly. I'm willing to, know anything you are interested.
Yeah,
Thank you.
excellent. Excellent, everyone. Then thank you very much, Tomoya, for your presentation and for all the attendance and excellent questions that we got here. And now we know a little bit more about Kubernetes and its use in edge situations. Thank you very much, everyone.
Yeah, thank you. Bye.
Bye-bye.